Assalamu alaikum. In the last lecture, we were talking about software configuration management. We had a brief introduction of basic concepts and terminologies in that lecture. We will continue our discussion on software configuration management today, and we will start this lecture where we left the last lecture, that is the software configuration management functions, or SCM functions. I'm sure you remember that SCM has 5 main functions. They are identification of configuration items, version control, change control, configuration auditing, and status accounting or reporting. Today we will discuss each one of them in more detail, and then we will discuss a very important concept, and that is change control process. We need to have a very formal change control process in order to have a successful procedure for software configuration management. To control and manage software configuration items, each item must be separately named or numbered. This identification scheme is documented in the software configuration management plan, and each item is referred to by its name or number. Some use the terminology of label to denote the identification number. This number is so unique that if we have different versions of one document, let's say requirements document, and this document has several versions, then the identification number would contain the version number also. So we can individually and accurately store it and retrieve it. So for accurate storage and retrieval, and for proper organization of the project database, we must have uniquely identified number for each software configuration item. And the number of items will continue to grow as the software project proceeds further. Makes progress, that this number will increase till the end of the project. The second SCM function is version control. Version control combines procedures and tools to manage different versions of configuration items that are created during the software process. The naming scheme, as I've said, for SCI should incorporate that version number. And organizations which are producing software products which have different version, this version control is an important and integral part of their software configuration management policy and procedures. Configuration management allows the user to specify alternative configurations of the software. That is, you can have different versions of the same software system or software work products. And the users of the software configuration management system should be able to select a specific version. They should also be allowed to create a new version. And so that support also has to be part of the software configuration management. This creating of new work products based on an existing work product is usually termed as branching, that we have a new branch of development where we can make changes, and depending on the project's needs and specific situations, those two branches may be merged later on. And all of these things are done through the software configuration management system. And the help of software tools that implement configuration management policies are utilized. To perform these activities manually is very difficult, almost impossible. So when we are implementing version controls, we typically allocate or assign attributes with each software version and then allow a configuration to be specified and constructed by describing the set of attributes. So for example, we can say, I need version 1.1 of requirements document. These are those attributes 1.1 that are attached to the requirements document in addition to the identification that has been given as the first step in software configuration management activities. And so version control, as you will see later, is an important part, because if you take, for example, a corporation or software organization like Microsoft, which has different versions of operating systems, and within different versions they have patches that they issue to their customers. They have different revisions, and so is the case with other operating system. For example, Linux, that has several versions, and then within versions they have revisions that are released for the customers. So any configuration management policy must have comprehensive policy and procedures implemented for version control and management. The third SCM function is change control. Change control is very important. It is vital, because if you have too much change control, we create problems. And if we have too little change control, we create another set of problems. And for large projects, uncontrolled change rapidly leads to chaos. And for medium to large projects, change control combines human procedures and automated tools to provide a mechanism for the control of change. And changes will occur in all software development processes, whether they are in the beginning of the project, that is requirements or design, or when the project is being initiated at the statement of work level, or when the project is being tested, and even when delivered. Actually, even after the product has been released to the customer will request new things to be added, will request certain things to be changed. And so the requests for change in software projects will continue to come long after the product has even been delivered to the customer. That's the nature of software. That's why we say that software is like a sponge, because it's susceptible to changes. We will talk about the change control process in today's lecture. First, let me introduce all the different SCM functions. The fourth SCM function is configuration audit. This enables us to ensure that the approved changes have actually been implemented. In the last lecture, we talked about two mechanisms that can be used to ensure that the changes have actually been implemented. We said that formal technical reviews or inspections can be applied, or software configuration audit can be done. The software inspections, or formal technical reviews as they are called, are a means to verify the correctness of the changes, and they are a complementary approach to software configuration audit, which asks for and looks for a different set of questions and different sets of areas, comparing that to a review. An SCM audit is conducted by the quality assurance group, while the reviews and inspections in that case are conducted by the development team or headed by the facilitator or the moderator. We also talked about the fact in last lecture that we will be asking certain questions, and when the discussion for configuration audit is held in more detail. So when a configuration audit is conducted, SCM, that is the software configuration management as a whole, needs to ask and answer the following questions. There are 6 of them. Number 1, has the change specified in the engineering change order, that is the approval order for changes, been made? That is, have the changes been implemented as desired or as approved? And another question that is a corollary of this is that have any additional modifications or changes been incorporated? This question will help us in ensuring that appropriate testing and SQA activities have taken place on those changes. The second question is, has a formal technical review or inspection has been conducted to assess technical correctness? And this is a complementary approach to performing the software configuration audit, as was just mentioned. This activity, that is the inspection or formal technical review, will ensure that the changes that have been approved were correctly implemented. And as you can remember from our discussions on software inspections, that inspections are the best means to ensure that changes have been made and to find defects if there are any. The third question that SCM audit needs to ask and answer before an audit is complete is, has the software process been followed, and have the software engineering standards been properly applied? An organization may choose any standard depending on the business needs. It may choose to implement any software development process and other processes like SQA process, like SCM process, like project management processes. But whatever processes have been selected, have they been followed faithfully? And if that process has not been followed faithfully, has a deviation been recorded and approved accordingly? This is going to help us in validation of the process of implementing changes and process of performing different activities in software development lifecycle. The fourth question is, has the change been highlighted in the SCI? Have the change date and change author been specified? And do the attributes of the configuration item reflect the change? As you know, that every SCI has its contents depending on what the SCI is. And whenever you make a change, you need to highlight that within that SCI. You need to mention the date when the change was implemented. You need to mention the author of the person, the name of the person who made the change. And the attributes of the SCI will actually reflect the change. That is, has the version number been, a new version number has been attached with that SCI or not. This question and the answers from this question will validate that we are following the identification functions properly, and that we actually have a new SCI, a new version of the SCI, so that if we want to go back and look at the previous SCI, we are able to do that. In case the changes have to be reverted, or another customer may want the original SCI. And so if you notice that the software configuration management process, if implemented faithfully, provides for all of these possible situations, and it keeps multiple versions of that work product, of that SCI or software configuration item, so that we can always go back to the previous items. The fifth question is, have SCM procedures for noting the change, recording the change, and reporting it have been following? This also is a validation mechanism and also relate to another SCM function, which is counting and reporting. And finally, the sixth question is, have all related SCI been properly updated? In many cases, when a change request is approved, it will impact other SCIs also. And all other SCIs which have been impacted by a change request in one SCI need to be updated accordingly, and we need to run tests and SQA activities to those SCIs also, and we need to ask these 6 questions for each of those additional SCIs which are impacted by the change in one SCI. So you see that this functionality that an SCM performs, or a software configuration management should perform, are very comprehensive in keeping our project alive and keeping previous versions available, and ensuring that whenever there is a change, it has been implemented correctly, and the impact of the change has also been understood, it has been reported, and it has been implemented accurately as well. Let us now talk about SCM functions related to status accounting and reporting. The status accounting and reporting provides a corporate memory for project events that supports accomplishment of other configuration items. We ask the questions: what happened, who did it, when did it happen, and what else will be affected. These 4 questions will help us to understand the changes that are requested, that are implemented, and if a new SCI is created, that will also be captured by these 4 questions. Each time an SCI, that is a software configuration item, is assigned a new or updated identification number, a configuration status reporting, or we call it in short as SCR, entry is made. So whenever there is a new SCI, or SCI is updated with respect to its ID, an SCI entry is recorded in the database. And each time a change is approved, a CSR, that is configuration status reporting entry, is made. So whenever a configuration audit is conducted, the results are updated in the SCR task. Output from the SCR may be, that is configuration status report, may be placed in an online database so that all participants of the project will have access to it. This will help everyone to be current with, to know what is happening, and the practitioners and managers will remain informed about important changes, the changes that they are particularly interested in, and overall if they are interested in looking at how the changes are happening. And the managers can use this activity, this function, to gauge the changes that are coming, the rate of changes that are coming, because the higher the rate of change, and that indicates certain problems. The rate of change of requirements especially should go down as we proceed into the software development activity. This data can then be used to educate and inform other projects within the software organization, and if the organization is interested in publishing that data to the research community, then that is also possible. Configuration status reporting plays a vital role in the success of a large software project. When many people are involved, it is likely that the left hand does not know what the right hand is doing. Syndrome would happen. And if we do not have a reporting mechanism in place, a good reporting mechanism in place, this can happen. And two developers may attempt to modify the same software configuration item with different and conflicting intents. One may want to change something in a function or a procedure, and another developer may want to make a change in the same function but with a different intent. And so this is possible if appropriate configuration management tasks are not implemented. A software engineering team may spend months or weeks of effort building software on an obsolete hardware specification. That is possible. A person who would recognize serious side effects of a proposed change is not aware that that change is being made. So if we have configuration status reporting in place, then it can help to eliminate these problems by improving communication among all people involved in the project. So SCM, status reporting and accounting, is a very important function that is an integral part of configuration management. This was our discussion on and a review on the functions performed by software configuration management. Let us now talk about change control process. As I have said before, that changes will happen. We need to allow changes, but we cannot allow all the changes all the time. We need to manage it in such a way that we continue to progress, but we also continue to allow changes in the different work products of software project. Without proper safeguards, change control can retard progress and create unnecessary red tape. It is relatively easy to incorporate changes in work product which have not been baselined. These are the work products which are still under development. And in those cases, the author or the developer has the authority to incorporate changes depending on the organization's policies, project management's guidelines, and most importantly, the technical needs that have arisen because of the requirement of changes. And so we only need informal change control. This is very relatively easy scenario. However, when a work product has been baselined after conducting a formal technical review or inspection, we need a more formal change control process to incorporate changes. Now, there are two situations here. One is the software has not been released, but it has been baselined and put under the project database. At that level, or in those scenarios, we have formal but project level change control. However, when the project or the product is delivered to the customer, we need to have a strict formal change control process in place to incorporate any changes in the software product. Proposed changes to software work products are reviewed, then subjected to the agreement of project participants, and finally incorporated into the currently approved software configuration. Does everyone participate in the approval process? No. This requires that a separate authority or a committee or a board which reviews and approves all the change requests be established for every project from within the project participants. And so we have representation from different groups taking part in the project. This authority is known as Change Control Authority or Change Control Board. In the first case, we also call it CCA for Change Control Authority, and in the second case, we call it CCB for Change Control Board. We will be using these two terminologies interchangeably in this course. And so whenever I say Change Control Authority or CCA, it is equivalent to Change Control Board or CCB. A CCA or a CCB plays an active role in the project level change control and also in formal change control activities when software has been released to the customer. Typically, such an authority or a board consists of representatives from software group, from hardware group, from database engineering group, from support group, and marketing group. And also project management is part of this. Many organizations and many projects have customers representative also on that board. And that is really helpful in improving the productivity of this committee or this board. If customer participation is available, that is a blessing. And all the changes that are requested by the customer can be justified and explained, and it will help the rest of the committee members, the rest of the board members to appreciate reasons why this change is needed and why it should be approved. And so the size of the committee changes with the project. Larger projects have more people on this. Small projects have fewer people on this. And for very small projects, it is even allowed that a single member of a single person can be assigned a task of CCB, and typically that would be the project manager himself or herself. And whenever a change request is sent to the configuration control board, this board or authority assesses the change request on technical merit, on potential side effects, on overall impact on other configuration items and system functions, and it will also determine the projected cost of the change. And these are the main factors as to why the change should be incorporated. These are the factors that this board uses to assess the approval or rejection of a change request. In addition to these important factors, the Change Control Board may also assess the impact of changes beyond the SCI in question. So an SCI may ask questions like, how will the change affect hardware? Or how will the change affect performance of the software product? Another relevant question to be raised and answered satisfactorily at that time could be, how will the change modify customers' perception about the product? And this is especially true in those cases where the changes are requested by the customer or the user. But in certain situations where the change is related to shortening or reducing the functionality of the product, that request can be initiated from within the development organization. And so CCA or CCB, whichever nomenclature you choose to use, needs to look at and assess the changes from these perspectives. Another valid question at that time that can be raised is, how will the change affect product quality and reliability? And this is also a very important question, and the CCB must answer this question to their satisfaction, so that after, if they approve the change or they reject the change, this will be their responsibility. And so they need to thoroughly and formally address these concerns, raise these questions, and then make a judgment based on the answers that they have received. Typically, Change Control Board has the authority to approve or reject a change request. However, the Change Control Board can request for consideration and inclusion in the next iteration also, because the change may come at a later, at such a time where it would not be feasible to include these changes before that particular version of the software is being released to the customer. So when the time is short, the CCB can decide to include the changes in the next release of the software, or changes to be made in the next iteration of the software development. This is especially true because we are now moving towards iterative software development. We are not using a single iteration based software development processes anymore. So the releases or the software product is given to the customer in increments, and the development is done in different iterations. And in these cases, especially if the representative from the customer is present, then that person can be explained, and his or her consent be obtained to make such a decision. For every approved change request, an engineering change order, or we call it ECO, is generated, which describes three things. Number one, the change to be made or the changes to be made. Number 2, the constraints that must be respected vis-a-vis that change, and the criteria of review and audit. So the change control board, when it approves a change, also provides the constraints and the criteria for review and audit. Now let's assume that a change has been approved. So the changes in the work product have to be done. And so the first thing would be to check out that configuration item from the project database. At this time, we have the access and authorization to make modification to that specific software configuration item. Before that, before checking it out, we did not have that authorization because it was part of the project database. At this time, the approved changes are made and necessary SQA and testing activities are applied to the SCI. Once we are satisfied that SCI is checked in to the project database, these changes are now part of the new version of the baseline work product. So whenever we have implemented changes, we have applied the SQA activities, we have applied the testing activities, now we check this work product, the modified work product, with changed version number into the project database. Now I will describe to you the change control process in a more formal manner. 3 slides to be inserted. Here you are looking at the change control process. This is the first slide. The first step is there is a need for change. That need for change is recognized. The second step is change request from the user, which is given to the developer who evaluates. A change report is generated. The change report is given to the change control authority for review and approval. Here you have 2 possibilities. Either the request is denied, as you can see that marked. In that case, the user is informed and the process ends. The second situation is that the request is queued for action, which means that it has been approved. Now we go to the next slide, which continues from the queuing of the request. The first activity at that time would be to assign people to make changes to the SCI. That SCI is checked out from the project databases. Then the changes are made. Once the changes are made, the review and audit of the changes are conducted, and all the testing activity that has to be done is done here. And we establish a baseline for testing. Then we move to the third slide and continue, and the first thing we do is perform SQA and testing activities. Once we are satisfied with the result of testing activities, we check in the changed SCI. Following that, we promote the SCI for inclusion in the next release. So whenever the next software release is given to the customer, this changed SCI will be part of that release. The rest of the steps are like that. We rebuild the appropriate version, we review and audit the change, and we include all changes in the release. As you have noticed, I'm sure, that the formal change control process is very elaborate and comprehensive process. We have to take every step with care, very formally, and perform all the necessary steps, perform all the necessary tasks that are associated with each step in this process. The check-in and the check-out activities implement two important elements of change control. They are access control and synchronization control. Access control governs which software engineers have the authority to access and modify a particular configuration item. As you know, it is not possible to give access of all software configuration items to every software engineer in the project, especially for large projects. And the second control mechanism is synchronization control, which helps to ensure that parallel changes performed by two different people don't overwrite one another. We need to implement both access control and synchronization control in our change control process. And typically, this is done with the help of configuration management tools. Now, you are looking at the access and synchronization control. This picture shows you how the access control procedure authorizes and manages the check-in and check-out requests by a software engineer for a configuration item, which is stored in the project database. And so this was the role of a very important role of access control. As I have said before, that it is not possible, it is not prudent to give access of all the software components contained in the project database to every software engineer working on the project. Typically, what happens is that people who are involved in developing specific modules or developing specific libraries or components are given access to only those libraries or modules or components. And certain key members of the project team, which include team lead and project managers, they have access to all software code. They are allowed to modify and get access to before they modify the products, work products that even others have developed. This is an important element of our software configuration management policy. And every organization must have an SCM policy, an SCM plan for projects. Now, I'm going to show you another picture which captures or which provides the software configuration management overview. It shows the database, it shows different activities, and it shows the flow of information or flow of data also. So here you are looking at software configuration management overview. Initially you have requirements or design or use activity, and then you have initial development, which is after that you need to establish a baseline. Then there's an activity. If you are updating a baseline, you validate that and then you authorize change activity. Then there is implement change activity, and after a change has been implemented, you validate a change, and the changes are then put into the project database. And as you can see, this picture gives you an overall set of activities, their relationships that exist for software configuration management. There are a number of standards that have been proposed, and these standards have been modified with the advancement in processes and with the advancement in technology. And so there are DoD standards, there are MIL standards, there are ANSI and IEEE standards for software configuration management. Depending on the needs of the customers, depending on the area of business that a software organization is operating in, it is important that every organization which is developing software, which has customers, should adopt SCM standard. It is not necessary that they follow one specific standard, but what is important is they must have or must follow or adopt an SCM standard. Software configuration management is an umbrella activity that is applied throughout the software process. That is, it is applied to all activities in software development lifecycle. SCM identifies, controls, audits, and reports modification that invariably occur while software is being developed and even in maintenance. SCM saves a project from total chaos. We must, that is, software professionals and software organizations, must understand and implement SCM policies, procedures, and use software configuration management tools that make these, which enable the implementation of these policies and procedures very reasonably easy. If you try to implement them manually, it is really difficult. And so today, these are the topics that we have covered. We have had a good introduction of what the SCM functions are, and we also talked about change control process in quite a bit of detail. We will talk about other topics related to SCM in our next lecture. Till then, I take leave of you. Allah Hafiz.